Hello, we are asked in this problem to look at an application. So we have years. I'm going to use my years as years since 2000. Excuse me there. So this would be year 3, year 4, year 5, 6, 7, 8, 9, and 10. It would have been equally as valid to start 2003 as year 0, and then it would be years since 2003, but years since 2000 makes it a little bit easier. So years since 2000. All right, so the table shows the number of units sold in thousands of existing apartments, condos, and co-ops in various years. The data is from the Statistical Abstract of the United States. The first thing that we're asked to do is to find an algebraic model for this data. So I'm going to go to my calculator with the data and just look at what the data looks like. So here I am at my calculator, and I went into Stat, and I went into Edit. And you can see that I entered the data from the table. So list 1 is the years, and I started at 3, and then list 2 is those number of units sold. And so then I went to set up my window. Now I have looked ahead in this problem, so I know that I want a bigger window because the next problem is going to ask me for the number of units sold in 2015. So when I went to my window, I set it to go from 0 to 15. And that would take me up to 2015. And then I just made this a big number. So my data went up to like almost 900. And so I just made it a whole lot bigger than that so I could see a big picture of what was going on. And in my y equals, I have my plot on, so I'll see the points, and I have all my equations clear. So taking a look at the graph, here are our data points. And there's some important things to observe that help me know which kind of algebraic model to make. So right here I see a maximum point, so that in my data was that 896. And right here I see a minimum point, and that in my data was the 563. So I have two extremes. So when I go back here, find an algebraic model, I have two extremes, or two extrema, to use our vocab word. So I have one maximum and I have one minimum. And we had talked about with polynomial graphs that the degree is supposed to equal 1 plus the number of extrema. So that means that for this problem where I have two extrema, I need the degree to be 3. So in my calculator, I'm going to pick cubic regression so that I have a function that will have the right number of extrema. So in order to pick the cubic, I go into Stat, over to Calculate, and down to item 6, cubic regression. So enter. And I am going to store this equation. So where it asks me to store it, I'll use vars, y variables, function, and store that in y1. And so I continue going, and I calculate that. And here is my equation. So I'm going to take a look at my graph of that equation before I go back and even write it down. So in my y equals, that equation is stored. And if I take a look at the graph, it does a phenomenal job of capturing this maximum point, capturing this minimum point, and really estimates the points in between very, very well. And so we see extremely good fit from this. So going back to answer my questions, find the algebraic model. And so we found a cubic model. And this is a lot of writing here, but let me write it out. So y equals, and I did round everything, 7.106 x to the third power minus 145.83 x to the second power plus 891.653 x to the first power, and then minus 833.548. So that is my model. Then it asks me to draw a sketch of the data and my model. So here is years since 2000. And we went the whole way out to 2015. And this is the number of units. And those are housing units that were sold. And we went up to 3,000. So our data was down here, and we had a maximum. And then it came down, and we had a minimum, and it came back up. So those dots are approximately how our data looked. And then we graphed our model, and our model did a really good job of coming through these. And then it really went up fast, so like that. And so then it asks me down here, what does your model predict for the units sold in 2015? And that is why we went out to 15 to look what the graph is doing. So we'll go back to our calculator to get that value. There's a couple options to find that value. I'm going to use the table. So first thing I'm going to do is look how my table's set up. And so I will start this at 15. And go up by ones, and then I will check out what my table says. And so here for 2015 the answer is 3,712. So prediction here is 3,712 units. Do you think the prediction is reasonable? No, I don't at all. It is so far from the other data. If I look at where the levels were in 2010, they were like at 600. And so to get from 600 up to 3,000, almost 4,000, would be a huge increase. And that is not at all consistent with the rest of the data. And so this brings us to what is one of the points from our notes, and that is that cubics fit data well. And we saw that in our graph. It really got incredibly close to both extrema and all the points in between. And so it can give us a beautiful fit for existing data, but they're not good at predicting. And that is because when we look at the overall shape of a cubic, this end that we did not draw is going down to negative infinity. This end that we did draw goes up to positive infinity. And data rarely goes to either positive or negative infinity. So the data is going to be clustered right around here. It may go up for a while. We have things happen in the market, etc., so it may climb for a while and then come back down, etc., but we don't think it's going to go towards infinity. And that is always the case with cubics because they always have this shape. So they do a fantastic job of fitting when there are two extrema, but they're not helpful in predicting, so they don't end up being used all that much in statistics.